So let's do some examples. First, I'd like to do an example involving the multiplication of a vector by a scalar. Let's say we have a character and an enemy. Now, our character is situated right here with an x component of 1 and a y component of 1 in two-dimensional space. Now, let's say that this character is a wizard and can launch a fireball, and that fireball can travel according to this vector here. Let's say that this vector, we'll call it v sub f. F stands for fireball. And v sub f has a x component of 2, so it travels 2 in the x, and a y component of 1, so it travels 1 in the y. It travels along this vector until it explodes right here. Now, our enemy is here, and we can see that our fireball is just shy of hitting the enemy. Now, let's say that our wizard gets some kind of a power-up. It drinks a potion, gets some kind of magical item, and now it can launch its fireball twice as far. So our power-up is going to multiply our vector v sub f by 2. And we know that we can scale a vector by 2 by simply multiplying its x and y by 2. So 2 times 2 gives us 4 for the x, and 1 times 2 gives us 2 for the y. So our new souped-up fireball can now launch twice as long. And if we draw this vector 4, 2 from our character's location, what does that look like? Well, let's draw it. Instead of our puny 2, 1 fireball, we now have a souped-up 4, 2 fireball, which means we can travel 4 in the x, 1, 2, 3, 4, and 2 in the y, 1, 2. So this is what our new fireball looks like. It can travel all the way to this location and explode right there. And as we can see, we can now hit the enemy from our character's location. So scaling the vector by 2 did the trick. So that's a nice simple 2D example. Let's do an example in 3 dimensions. Now let's say that we have a character on the ground. It has 0 for its z component in 3D space, but let's just say that its x and y are 2 and 2 respectively. So we have a point. It's 2, 2, 0. Now we know that a point in 3D space has x, y, z coordinates, and a vector in 3D space has x, y, z components. Well, we can take a point in 3D space that has coordinates, and we can store those coordinates in a vector. What happens when we store x, y, z coordinates from a location into a vector is we get what we call a location vector, or sometimes position vector. We can always think of a position vector as a vector starting at the origin and ending at that point in space. So the point 2, 2, 0 can be represented by the vector 2, 2, 0 if we place that vector such that its tail begins at the world origin. Now, we have this character at 2, 2, 0. Let's say they have a rocket launcher. And the rocket launcher can be described by a vector that represents its trajectory. Let's say that vector looks like this. And we'll give this vector some components. Let's say that this vector, we'll call this v sub r for rocket, is the vector 3, 0, 2. In other words, the rocket begins at our character's location and it travels 3 in the x, 0 in the y, and 2 in the z, and ends up here when it explodes. So we have 2 vectors. We have the vector representing our location. We'll call this v sub l. And we have the vector representing our rocket's trajectory, v sub r. And this vector begins at the head of v sub l. It begins at our character's location. So let's just say that we need to know the location of the explosion point. That way we know where to spawn some explosion particles and cause damage to whatever is at that location. So how do we do that? Well, we know that our character's location is 2, 2, 0, and that can be represented by a vector from the origin to that point, 2, 2, 0. Here's v sub l. And we know that we have the rocket trajectory represented by the vector v sub r, and that we've placed it so that its tail is at the head of v sub l. So this is v sub r. What we want are the coordinates in space for the explosion point. And we know that a point with coordinates can be represented by a vector from the origin. And v sub l starts at the origin. So really our problem boils down to this. We want to know this vector here, from the origin to the explosion point. Let's call this vector v sub e. Well, based on the geometrical significance of vectors, if we have vector v sub l positioned as such, and v sub r positioned as such, so that its tail is at the head of v sub l, then the vector from the starting point of v sub l to the ending point of v sub r is this vector v sub e. That's the vector we want. So this is just a vector addition problem. V sub l plus v sub r gives us the result v sub e, the explosion point, a location or position vector. Let's do the math. We know v sub l is 2, 2, 0. And we know v sub r, that's 3, 0, 2. So the result, v sub l plus v sub r, gives us the vector with x coordinate 2 plus 3, which is 5, 2 plus 0, which is 2, and 0 plus 2, which is 2. This is the result we're looking for. This is v sub e, 5, 2, 2. We'd have to travel 5 units in the x, 2 units in the y, and 2 units in the z to get to v sub e, our explosion point. V sub e. So this is a valuable lesson. This type of scenario occurs all the time. If you have a drone flying around in the world and you know its world location and you know, say, its forward vector, well, we can always calculate this point at the end of its forward vector by taking its location vector and the forward vector, adding them together, and the result is the location vector to the point in question. So this is a very valuable problem to be able to solve as a game developer, and we're going to get plenty of practice doing so in the engine. I'll see you soon.